The debate surrounding our origins is one of humanity's oldest and most profound conversations. Within this vast intellectual landscape, the concept of intelligent design, or ID, has emerged as a significant and often controversial voice. However, it is crucial to understand that not all ideas bearing this name are the same. Today, we must distinguish between two fundamentally different frameworks. The old intelligent design, championed by figures like Michael Behe and Stephen Meyer, and the new intelligent design, which is built upon a scientific discovery of intelligence itself. The old idea is primarily a critique of Darwinian evolution, arguing that certain biological systems are just too complex to have arisen through natural processes alone. In contrast, the new intelligent design, established by my work in 2011, is not a critique but a foundational scientific framework. The modern movement known as Old Intelligent Design gained prominence in the late 1980s and 1990s largely through the efforts of a group of scholars associated with the Discovery Institute. Key figures like biochemist Michael Behe, philosopher of science Stephen Meyer, and mathematician William Dembski became the public faces of this idea. The Discovery Institute's wedge strategy aimed to drive a wedge into the scientific establishment, making room for the idea of a designer in mainstream science and eventually, in public school classrooms. The goal was to teach the controversy, suggesting that Darwin's theory was a theory in crisis, and that intelligent design was a viable scientific competitor. This strategy culminated in one of the most famous legal battles over science education in American history, the 2005 Kitzmiller versus Dover Area School District trial. The presiding judge ultimately delivered a landmark ruling, concluding that intelligent design was not a scientific theory, but a form of creationism, effectively barring the teaching of old ID in public school science curricula. At the very heart of the old intelligent design argument was the concept of irreducible complexity. Behe used the analogy of a common mousetrap, a system that needs all its parts to function. The bacterial flagellum became the poster child for this concept. An incredibly intricate molecular machine composed of about 40 different protein parts. However, biologists argued that Behe's definition was flawed, and that it underestimated the power of natural selection to co-opt existing systems for new functions, a process known as exaptation. Ultimately, irreducible complexity became an argument from personal incredulity. Just because a particular scientist couldn't imagine how something evolved does not mean it is impossible. Despite its name, the old intelligent design movement had a conspicuous and critical blind spot. It never offered a scientific definition of intelligence. The intelligence was simply a placeholder, a label for the unknown cause of perceived complexity. It was defined by what it was not random chance, and it was not natural selection. Without a clear understanding of what intelligence is, how can one claim to detect its products? It's like trying to search for radio signals without knowing what a radio wave is. The foundation of their argument was not on the solid ground of a theory of intelligence but on the shifting sands of gaps in scientific knowledge. The landscape of the design debate shifted dramatically in 2011. This was the year Edgar Alberto Postrado, made a fundamental scientific discovery that provided what the old ID movement had always lacked: a clear, testable, and universal definition of intelligence. This discovery came from a direct investigation into the nature of intelligence and non-intelligence as distinct observable phenomena. Non-intelligence, such as the processes of physics and chemistry, operates through cause and effect. A cause happens, and an effect follows. There is no problem-solving involved. In stark contrast, intelligence does not just cause an effect, it solves a problem. But the act of solving one problem inherently creates a new secondary problem that must also be solved. For example, consider the problem of writing a book. The solution is to write sentences, but this creates a new problem. The sentences must be organized into coherent paragraphs, and so on. This framework can be applied to anything, from a computer program to a biological system, transforming the entire conversation from a philosophical dispute into a scientific inquiry. When we place the old and new intelligent designs side by side, the differences are stark and fundamental. The old ID begins with a critique of evolution. The new ID begins with a positive definition of intelligence. One is an argument from ignorance, the other is an argument from evidence. The old ID's method was oppositional and dependent on gaps. The new ID's method is independent and evidence-based. The new ID moves beyond the dead-end debate over evolution and opens up a new frontier: the scientific study of intelligence and its products wherever they may be found. Understanding this distinction is the key to moving the entire conversation about our origins forward into a more productive and evidence-based future.